Okay, here we go. An extension on the idea of dividing and multiplying rational expressions. So, first thing you probably want to do here is flip over the fractions that are supposed to be flipped when we're dividing. So we're dividing this fraction by this fraction, a rational expression if you will. We're not going to flip this one because this is just multiplication, but this one we should turn over. So we have x minus 11 over 2x plus 10 times x plus 5 over x squared minus 8x minus 33 times x plus 3 over x squared. So now we have our one big product, right? Now, multiplying across would be a horrible idea, right? Factor first, factor first, factor first. Can this be factored? 11 minus x minus 11, x minus 11. I'm camera shy. X minus 11, can it be factored? No. Can I factor anything out of 2x plus 10? I can factor out a 2. I don't know if I'm going to need to do that, but I can't factor it. So factor first. Divide the 2x and the 10, both by 2, remove it. Over here, we have x plus 5. Oh, I'm sorry, I forgot to do something. Sorry. Let's go back for a second. Remember what I said yesterday. If you have a binomial that cannot be factored, put parentheses around it. That becomes the factor itself. That will probably stop us from making a terrible mistake at some point. All right? That becomes the factor if it can't be factored. All right? Now over here, x plus 5. Can I factor anything from x plus 5? No. So x plus 5 becomes its own factor, right? It's what we call a prime binomial. It has no other factors besides itself. And then down here, a quadratic trinomial that I'm going to attempt to factor into binomials. I've got x squared, so I know x can go here and here. I need two numbers that multiply to be negative 33. There's only two numbers that multiply to be negative 33, and they are 3 and 11, and one of them is negative, right? So is there some combination of a positive and negative 3 or 11 that also add up to be negative 8? Yes, negative 11 and positive 3. And then over here, x plus 3 is prime, and x squared is x squared. Now, we haven't done this yet. I'm not saying I would suggest this, but maybe not on every problem. X squared is really x times x, so you could put both x's in parentheses, okay? We could have done that if you go back to this problem when we had x to the 5th and we said x to the 5th is x cubed times x squared. I wrote that as a product of powers because I saw one of those other powers over here. Now I don't see a ton of powers of x in this problem, but writing x squared as x times x, you never know if you're going to be able to cancel something there, right? So before we try to cross cancel, let's look within each rational expression separately and see. Anything cancel from here? I don't see any common. These are not, in common. The factor is x plus 5. I don't have an x plus 5 up here. Again, neither one of these is the same as this, so those won't cancel. And I can't cancel this x with this x because x plus 3 is the factor. That's why I have the parentheses around it. Okay? Anything enclosed in parentheses, that's the factor that I'm multiplying by something. But I can certainly do some cross-canceling, looking on a diagonal. Now you don't have to go just to the adjacent fraction. It doesn't just have to be the next one. When you're multiplying, multiplication is commutative, right? So you could take this and move it here and swap places with this. So I'm not going to do that. It doesn't make sense to do that. But my point is, you can multiply from here over to here. You could multiply cancel. You could cancel this numerator times this denominator. You can only do one at a time though, right? So, x minus 11 x minus 11. X plus 5, x plus 5, these are all canceling on the diagonals here. X plus 3, x plus 3. So on the top, this is 1, 1, 1. So all the way across the top, I have nothing, right? Nothing. But technically there's a 1 there when I cancel those factors out. On the bottom I have a 2, and then x squared that I separated, I didn't actually have to do that. Right? So I'm done here. You want to be really smart people here? No? Yeah? Yes you do. How about this? What about that? Or maybe this? Uh-oh. Yeah, I did that. X squared in the denominator. I mean, there's nothing wrong with this. Don't get me wrong. There's nothing wrong with this. But just to review some exponent rules, if you have x squared in the denominator, you can write that in the numerator with a negative exponent. Right? We always flip-flop where negative exponents are. There you go. Honors. Drop the mic.